available to us. Want to start on this first one you sent?
Yep. With the log stuff.
We can start anywhere. It looks like this is problem 99. I may not have opened it in the order that you sent. Let me look at photo 1.
Oh, that one was right. That's right.
Okay. In fact, photo 1 looks like the same thing. Okay. Let's talk about logs for a moment. The most important thing you can remember about logs is if y equals b to the x, express that logarithmically for me. This is the exponential expression. It would correspond to something like 8 equals 2 to the third. What is the logarithmic expression of this?
Y equals 8 and B equals 2?
By that I meant log. The only thing you ever have to remember to convert an exponential expression is that logs are exponents. That's what logs are, is they're the exponent. So when I tell you, or you tell me that y equals b to the x, I know immediately that the log of something equals x, because logs are exponents. Well, we need to put the b and the y someplace. Well, the b always goes there. Only place left for the y is there. So these two are the same.
Okay.
Express this.
What does log mean? What does log mean?
Logs are exponents. That's what they are. Logs are exponents.
Okay.
Okay? So based on that, express that logarithmically for me.
So it'd be log 2 times sub 2.
Right? Of what?
Times 8.
Equals?
3.
Okay. Now, the way this is verbalized is, at least this is the way I do it. Your teacher may do it differently. 8 is the argument. 2 is the base. And 3 is the exponent. So I would say this is log base 2 of 8 equals 3. It's definitely not log times 8. Okay? It's more like a function. If I say this, that means a function of x. It doesn't mean f times x.
All right.
Okay? So this, understanding this relationship is gigantic. If you hope to understand logs at all, you must memorize this. And it's not hard, as all you have to remember is that logs are exponents. All right, let's look to your homework here. Wow. Okay, what is going on here? Let me move my mouse away. Lately I'm getting interference between my mouse and my cursor. My cursor is wireless and my mouse is wireless, and when I get too near one another, my computer starts going nuts. Wow, in fact, it opened up photo 2 when I didn't want it to. Let's go back to photo 1. Okay, convert log base 4 of x equals y into exponential form. In other words, if something is in logarithmic form, we can convert it to exponential form, and if something's in exponential form, we can convert it to logarithmic form. So what's log base 4 of x equals y? What would that be in exponential form? Let me give you a little hint here. I have a nice, easy way of memorizing this. Take the number on the far left,
Yeah.
raised to the raised to the number on the far right equals the number in the middle. So it's real easy. It's 4 to the y equals x. And that's the way you always want to do it. Rather than trying to figure out how to do this backwards, which is essentially what we're doing, just remember when you're going from logs to exponentials, it's the number on the far left raised to the power of the number on the far right equals the number in the middle.
Okay.
Okay. Now let's go the other way. No, I'm sorry, not the other way. Let's go the same way. Write log of x equals 4/5 in exponential form. What's the base of this log? It's always 10 if it's not specified.
Okay.
In other words, this is the same as this. So if there's no base, it's log base 10. So when we convert this to exponential, what's it going to be?
It'll be, sorry, bxb.
Hold on. There's a 10 here.
Oh, the 10. All right, so it'd be x equals 10 and 4/5.
If you're going to use that little memorization technique, then let's start the left side of this thing as 10 to the 4/5 equals x. We don't need to start it with x. It just ruins our flow.
All right.
In other words, if you're going to start with the number on the left raised to the exponent of the number on the right, that's what you want to start with. You don't want to try to do all of that backwards.
All right.
Okay? All right. Let's look at 101. With logs, there's 3 rules that are gigantic. I'm going to list them right here. In fact, maybe you can tell me what they are. What is the log of A times B equal to?
AB.
It equals the log of A plus the log of B. Okay? That's rule number 1.
Okay.
Rule number 2. What is the log of A divided by B equal to?
Log of A times log of B?
Minus.
Oh, minus, okay.
Remember that logs are exponents. And when you work with exponents and you're multiplying, you add the exponents, right? So as Rule 1 is saying is that, well, if I have x to the 3rd times x to the 4th, that's equal to x to the 7th. Notice that I was multiplying and I turned it into addition. I'm adding the logs. Remember, logs are exponents. And the third most important rule is the log of A raised to the B power. This is exponentiation. Each of these was one level less mathematically. When we were multiplying, we added. When we are dividing, we subtract. And when we are exponentiating, we multiply. In other words, you can take that exponent and bring it right down.
Oh.
Okay? So let's give an example of rule number 1. The log of 6 is equal to the log of 3 times 2.
Okay.
Which means it's equal to the log of 3 plus the log of 2. That's how rule 1 is applied. And they want you to be able to go both ways. They want you to be able to expand it, or they want you to be able to condense it. Given the right half of this equation, they want to know you can put it into the log of 3 times 2 or the log of 6.
Yeah.
Okay? All right, let's go through some of these problems, and I'll leave these rules up here. Let's look at 101. 4 log b to the r, and here they want us to condense it, which means it's already expanded. It's going to,
Right.
we're going to look for it on the right side of these equations, and we want to switch it back to the form of the left side of the equations. So what can I do with this 4 based on rule number 3? Based on rule number 3,
Yeah.
means that log 4 times the log base b of r must equal the log base b of r to the 4th power. Excuse me.
Oh.
I don't want to write the b too large here. There you go. In other words, the first thing we do when we condense it is reverse this based on Rule 3. Rule 3 says that if you have b times the log of a, you can take the b and make it the exponent of a. Okay? So the last one, 3 log base b of t, what's that equal to?
To log bt to the power of 3.
Okay, make sure you say that word b, base rather. In other words, when you're going to verbalize this, make sure you say log base b of t. Because when you just say log of bt, it's different. I could think that the argument would be bt. So when you're talking logs, it's important to verbalize it properly. So I'm going to raise that one to the 3rd. So on the bottom, I'm going to write what we have. We have the log base b of r to the 4th plus the log base b of s minus the log base b of t to the 3rd, right? That's the first step in condensing it.
Yeah.
See how we get those 3? Okay, we haven't fully condensed it yet because based on Rule 1 and Rule 2, I can do more. I can turn this whole expression into the log base b. Well, I'm adding r to the 4th plus s. Therefore, I'm going to multiply those. And I'm subtracting t to the 3rd. So there's your answer. That's fully compressed. And do you see why? I don't want to go on if you don't get this.
Yeah.
Okay. Let's look at 102. I'm going to leave these 3 rules up here.
Okay.
Let's compress 102.
Well, I do have another question.
Okay.
If, like, for 102, are we supposed to change it to, is it just backwards for Rule 2? So it would be
Yes.
log,
Whenever. Go ahead.
it would be, hold on a second. It would be log 500 over 25?
Correct. But now they want it as a single log, and this is kind of like a radical. If I don't want to give this as an answer, I want to simplify it. Okay, so what can I do? I can divide 500 into 25. That's 20. So this whole thing is the log base b of 20. If you put this into your calculator, find the, well, they don't give you a base, so you can't, but you get what I'm saying. If we had a base there, we'd be able to verify that. In fact, that is the way slide rules used to work. is slide rule worked because it was all the log scales. All the things you slid were log scales. So when you want to multiply two numbers together, you basically add their log scales. Okay? So let's condense this. Let's do it in 2 steps. What's this condensed to?
The 6 log base B2.
Uh-huh.
It would be, you just multiply the 6 and the 2, right?
Don't multiply it. You make the 6 the exponent of the 2.
Well, so it would be log base B2 to the power of 6.
It'd be log base B of 2 to the power of 6.
Of to the power of 6.
Uh-huh. Okay. All right. What's the second, the middle term going to be? Plus,
You read that down one second. Log.
you'll have access to this recording also.
All right.
So you can review it because you're going to want to probably, with these logs, there's enough of these rules.
Yeah.
So the middle term becomes what?
Could be log base B of 9 to the power of 1/2.
Okay, which means the square root of 9. So we can change that to 3 when we get around to it. And minus the last one, we don't have a first step for it. Okay.
Log base B.
I just wrote it. In other words, there's nothing else to be done to that. Okay,
Yeah.
now though we can compress all 3. Let's do it into 1 log. In other words, I'm going to have, since they're all base B, if they were different bases, I wouldn't be able to do that incidentally. But what I'm going to do is make 1 argument. Instead of 3 different logs, I'm going to have a single log with 1 argument. What's in the inside here?
It would be. Oh, but I have a question. So is it kind of just normal? You just go from left to right, just like so. We would take care of the log,
Yes.
base B2
Yes.
6 plus that, and then you would go in to make it a like rule number 2. So in the end, it's going to be looking like a log A over B.
Well, let's do it.
All right.
So what's the numerator? Based on this right here, what's the numerator? Remember, the numerator is always going to be whatever's being added together, and the denominator is going to be whatever's being subtracted. So I could have a string of 6 different items in this last expression and combine them all into 1 log as long as they're all being added or subtracted.
Right.
Okay, so what's in my numerator?
Could be 2 power to 6.
Okay. Times what?
9 times 9 power of 1/2.
Which
or 3.
is square root of 9, so I'm going to write a 3 there. Divided by what?
Divided by, and that's where the log base 3
Just
comes
3.
in?
Just 3.
Yes.
Yes.
Oh, okay.
Yes. That's where we divide by that because that's what's being subtracted.
Okay.
Okay. Well, our 3's cancel. 2 to the 6th is 64. So it's log base B of 64. That's your answer there. In other words, after you get it into a single log expression, you want to reduce it as much as you can.
Yeah.
Okay.
All right, cool.
Okay, now in 104 through 106, we're doing exactly the same thing, only we're going in the other direction. We are expanding these, not compressing them. Hold on. When I put my mouse away, I have to navigate my computer with this cursor, which isn't quite as easy. So if we're going to expand this, what's it going to look like? So all we're doing is going the other direction. So we've got three things as part of this argument. So we're probably going to have this one plus this one minus this one.
Right, so it's going to be log base b p to the power 4 plus log base b q to the power negative 3 minus log base b r to the power 1.
Or just r. Okay?
Or just r.
That's first step. We're not done because we've still got more we can do to this thing here.
What else?
Well, we've got an exponent here. We can bring that exponent in front.
Oh, you put, so it'd be, wait a second, so then the next step would be, it'd be 4 times log base BP.
Okay.
Yeah, and then log base BP plus negative 3 log base BQ minus log base BR.
And notice the middle term goes from plus to minus.
Yeah.
We're going to get rid of that and make it a subtraction. So now, actually, if I recompress this, I would end up with a different expression. But not really. Notice that the expression they gave us, q to the third, could have gone in the denominator as q to the third.
Yeah.
So it would have still ended up exactly the same after expanding.
Right.
Okay, so expand be 105 for me.
And what? Oh.
105. Let's do it in 2 steps. Expand the numerator and then expand the denominator.
So it'd be log.
I'm gonna omit the writing the b just to save myself pencil cramp.
All right. All right. Log sub b a to the 5th plus b. Sorry. Plus log sub b b to the 9th minus log sub b c plus log.
Okay, that last one has to be a minus. Notice why it has to be a minus, because d is in the denominator.
Oh, okay.
So it has
so
to.
No matter what, it has to be minus.
Yeah, I could make it a plus if I wanted to do this, but watch what I have to do. I have to put parentheses around it, like that.
Okay.
Well, by doing that, it's the same thing as making it a minus without the parentheses. And just always remember that if something's in the denominator, you're going to put a negative sign in front of it.
Yeah.
So what's the last step here? Because this is still not fully expanded.
Right, so then the next step would be 5 log sub BA plus 9 log sub BB minus log sub BC minus 12 log sub BD.
Okay. Pretty straightforward once you do a few of them.
Yep.
Well, let's not write this. Just read this, and let's try to do it all in one step. 105.
What it? 106?
No, 105. Did we just do? Oh, we just did 105. Okay, well,
Yeah.
Let's do 106. And do you know what ln means?
No.
It means log base e is equal to ln. So whenever you
What does
see
that mean?
ln, it's called natural log. E is the number, it's an irrational number, but it's approximately equal to that. So why it's significant, E is one of the most important numbers in mathematics, probably second only to pi. And it has tremendous applications when you take calculus. Everything is done in natural logs rather than logs.
Yeah.
So you'll run into this a lot. Don't be confused by it. It just means log base E, and it's written natural log. So you know the base of this is E.
All right.
Okay? Doesn't change our rules at all, just like none of these rules changed because it was log base B instead of log base Z. Okay? So the rules are exactly the same. So expand that for me.
Oh. Okay, so it'd be, let's see.
Do it in one step instead of two steps.
Okay, so it'd be 2 log
Natural log.
ln, yeah, sorry. 2 ln sub b, or is it sub e?
R.
There's no sub?
It's the argument. The sub is defined by the natural log. That means we don't have to write the base. That assumes a base of E, just like this assumes a base of 10. If I just write log with no base, it means log base 10. Same way that if I write natural log without a base, it means log base E. Okay? That's why you say natural log instead of log base E. You say it in one word, natural log, and then you don't have to say the base. Okay, what's the rest of this?
Then it goes to minus ln s minus 6 ln t.
You got it. All right. Evaluate each log. Hold on a second.
Is this where you just like punch it in the calculator?
No, I don't think so. Well, maybe. Hold on a second. Let me evaluate each logarithm. I hope not, because that's not much of an exercise. Actually, you can't do that with this one, punching it into your calculator. And the reason is that your calculator doesn't have a log base 9 on it. Your calculator only has 2 keys. One is log base 10, the common log. The other is natural log, which is log base E. So to do a log on your calculator that is not one of those 2, you have to use the change of base formula. Well, let me give you that. The log base B of A is equal to the log base anything of B divided by the log of, it's the log of the big number A divided by the log of the little number B. And this B is not the base. It's also equal to the natural log of A divided by the natural log of B. It's also equal to the log base 117 of A divided by the log base 117 of B. In other words, any log ratio of A over B gives you this. So you're right, it's a calculator problem, but 107 is equal to the log base anything. In other words, you can use your log key on your calculator, or you can use your natural log key on your calculator. Do you have your calculator in front of you?
Yes.
Go ahead and do this one. Use your common log key. Take the log of 6561 and divide it by the log of 9.
Got 4.
Okay, so that's 4. So what is that telling us? If the log of base B of 6561 is equal to 4, which is what you just told me,
Yeah.
what does that mean? Change that into an exponential expression. If the log base 9 of 6561 is equal to 4, what's the exponential expression for that?
Oh, it would be 60
Well, the number on the far left
goes in the main one.
raised to the power on the far right.
9 to the power of 4 equals 65, 61.
There you go.
I was just going to say the opposite, but yeah.
Well, I know it, but I stopped you because if you're memorizing stuff, you don't want to switch it around, even though they're the same thing. In other words, even though 6561 is equal to 9 to the 4th, that's not the way I memorize it. Now, if you have your own way of memorizing it, then far be for me to interfere with that. But if you're going to use my little rule that the number on the far left raised to the power of the number on the far right equals the number in the middle, then that's the way you want to write it. My rule doesn't say the number in the middle equals the number on the far left to the raised to the power of the far right. I guess you could memorize it like that, and if that's the way you do it, that's the way you'd want to do it every time. The secret to memorizing is to find a pattern and stick with it. Don't mix it up when you're memorizing stuff. Seems like a trivial thing, but I think it's important.
Yeah.
So
No, that makes sense.
evaluate the common log of 145. What's that?
That's the same thing as punching it in, right?
Right, because you do have a LOG key on your calculator.
Yeah. Yeah. I got 2.16.
2.16. So what does that mean if I evaluate it exponentially?
Wouldn't that just be like...
There's a 10 right there.
Oh yeah, it's 10 equals 2, oh no.
No?
10 to the power of...
Say it.
I don't know.
It's the number on the far left raised to the power of the number on the far right equals the number in the middle.
But there's only one other number, the 2...
No, there's 3 numbers. Right. So it's 10 raised to the 2.16 power equals 140.
145, okay.
And if you do it the same way every time, you will never have a problem with this.
Right.
Just don't mix it up. It's real straightforward. It's the number on the far left raised to that.
Yeah.
Okay. And finally, 109. You have an LN key on your calculator also.
Mm-hmm.
So what's the natural log of 25?
3.21, which would be... Right.
Express this exponentially.
Now for the ln, it's still going to be like 10 to the power of 3.21 equals 25.
It's not a 10 though. What's the base of the ln function?
I don't remember.
E. E.
E?
E.
Yeah.
The number E. So it's E, that's the base that's implied when I write that.
Okay.
So it's E raised to the 3.21 power equals 25. Go in your calculator and take E and raise it to the 3.21 power.
You get almost 25. I got 24.77.
Exactly. And the reason it's not exactly is because we rounded that off. The natural log of 25 was actually 3.21 and change. Okay?
Okay.
Okay, but it's very important. This knowing how to go back and forth between exponential expression and logarithmic expression is huge because that's what you have to do to solve equations. This is the last question on this page. Yeah. Let's open up photo 2. Let's see. Oops. Completely oh, this is all different stuff. Okay. That's because you're preparing for your final and you have all this different stuff, huh?
Yeah.
All right. If we're man. What's the greatest common factor that you can take out of each of these three terms? Start with the number. We'll do it piece by piece. Start with the number and then go to the next variable and then go to the next variable. It's the greatest common factor. Okay, so 8. How many x? Okay.
And then y to the power 2.
Okay. Now, what's left over? In other words, to factor it, that's the greatest common factor, but you need to come up with the rest of it. In other words, this times this is going to equal what we started with. The way to do it is to divide your first term by this entire expression. In other words, you're going to take 16xy to the third and divide it by 8xy squared. What do you get?
1x.
No, the x's cancel.
Oh, yeah. So 2y.
Okay, that's the first term. What's the second term?
2x.
No, not 2 anymore. When we divide that by 8, we lose the number. It becomes 1.
Right. So it's just x.
Okay.
And then y to y to the fifth.
Minus
6. Then x to the third. And then that's it.
Good.
Because the y's cancel out.
Okay, so that's the answer. So that's all it is finding the greatest common factor and then dividing that expression into each term. Okay.
Just for each one.
Right, so let's do 111. So we start with this. First of all, find the greatest common number.
Would it be, no.
I'll give you a hint. It's a single-digit number. I'll give you another hint. Find the only number that divides into 42 and 35 evenly.
Three.
3 doesn't divide into 35.
Oh,
See, this is where a calculator doesn't really help you much. But knowing your times tables and division tables would help you immensely.
yeah.
That's why people who are dependent on a calculator have such problems in algebra. Because you can't be dependent on a calculator. You just have no hope in algebra if you are. So if you really want to be good at this stuff, you need to work on being able to figure out what number goes into both 42 and 35. It
Is
would
it
be
just
7.
7?
And
Oh, okay.
7 happens to go into 56 also. But you would need to know that 7 times 8 is equal to 56, 7 times 6 is equal to 42, and 7 times 5 is equal to 35. So 7 is the number that's the part of the greatest common factor. What's the letter?
Z.
Okay.
7Z.
What's left over?
And then it's 50. It's 8. 8, and that's it. Then minus 6Z minus 5 Z to the 4th.
Okay. All right. And last one there. Okay, now this is a little different factoring problem. What's different about this factoring problem is that there is no greatest common factor.
Right.
It's a quadratic. And usually that's the case with quadratics if they have a number. So this just requires you to factor it normally. Now we factor that quadratic.
So I know it's X.
Always start there.
Yeah.
Okay. Now the next step, very key, is to examine the sign of the constant. If that's a plus, what does it mean about these two signs here?
That they're going to be pluses.
Or minuses. They have to be the same.
Right.
They have to be the same. That's what it tells us. Either has to be plus plus or minus minus, and to determine which, we look to the sign of the middle term.
Right. And
Since
that just shows.
Plus, it's got to be plus plus.
Right.
Now what?
So now it would be
Factors.
find the two numbers that
Factors of 10.
add up to 10.
No. Factors of 10. In other words, two numbers that multiply to 10 have to add up to 7. And not plus 7, but 7. In other words, I'm going to ignore that sign for the moment. Those factors have to add up to that. Well, that's 5 and 2, and it doesn't matter whether we put the 2 here and the 5 here or this way.
Right.
Okay. If that was a minus 7, let's factor this one. Everything's pretty much the same, except we examine that. That says plus plus or minus minus. This minus says that it's minus minus. And now we still want factors of 10 that add to the number 7. not that add to the number minus 7, but that add to 7. So it's still 5 and 2. Okay?
Right.
Okay. Hold on, let me shrink this the normal way. Okay, a typical quadratic that we need to factor. X squared plus 20x plus 64. Get me started.
It would start off with x is the first one in each of them. Then we have to find the what is the
sign. The next step is to determine the signs that are going to go with each of them also.
Yeah. And it's plus plus.
Now, what's the rule we're looking for?
The two numbers that are left have to multiply to equal 64 and then add it equal 20.
Okay. Well, it's not 8 and 8, is it?
No.
Okay, so let's experiment, meaning we have to make one of them bigger and one of them smaller.
Right.
And let's look at that technique. If 8 times 8 is equal to 64,
right.
What if I double the 8 and half the 8? Doesn't that have to be true?
Yeah.
Without knowing that 16 times 4 is equal to 64, you could figure it out just by doing that. And
oh, okay. Oh, yeah, that makes sense because since both of them together are that.
Right, because I've doubled this, I've halved this one.
Right.
So if you weren't aware that 16 times 4 was equal to 64, you could kind of find it out by playing around with what you know to be true, which is 8 times 8 is 64.
Right.
So 16 and 4 are our answers. That works in a lot of things. If you know that 12 times 12 is equal to 144, that means 24 times 6 is also equal to that. And in fact, if I take 3/4 of 12, that's 9, and take 4/3 of this 12, that's 16, that's also equal to 144. So when you're factoring stuff, it helps to know those little tricks. All right, this one's a little harder, although not that much, really. It's not really harder, it just has a different aspect to it.
Right.
How do I begin here?
The x is on each side.
Well, that wouldn't produce 5x squared. In other words, the way you determine
5x and then x.
In other words, those two starting spots always have to produce this first term.
Right.
Okay. Now we look, what's next?
The signs are both minus subtraction.
Okay. And now what?
Two numbers times each other equals 7, and then added together equal 12.
Since 7 is prime, the only factors that 7 has are 7 and 1.
Right.
So it's either 7 and 1 or 1 and 7. Well, notice the 1 and 7 produce minus 36x, whereas the 7 and the 1 give us the exact right answer. And how do I know? Okay, first of all, let's talk about this. Verifying our factoring. Once you've finished factoring, you want to do a quick check to make sure you've done it right. Well, we don't have to check that term. We produced it based on that term. We don't have to check that term. We know both of those terms are right. term we need to check is to make sure we get minus 12x in the middle. Well, I like to call that my smiley faces, because I connect the two inside terms, which gives us minus 7x, and I connect the two outside terms, which gives us minus 5x. And then I add those two numbers together. That should be my middle term, and it is. So I've done it correctly.
Right.
Now, what's particularly different about these is if that is a minus sign. Let's just do number 115, and I won't have to make up a problem.
All right, well, let's see. I've already finished the rest of the 115, 16, 17, 18.
Okay. Shall we go to the next page?
I did those in class a while ago. So.
Okay. Let's go to...
Oh, that just reminded me. I have a question.
Sure.
Are you available the rest of the, like some other time today? Or
Yeah. Yeah.
'cause I know I want to keep working with you on this.
Okay. Yeah. When would you like to do it?
I'm not 100% sure, but I'll just get online and...
Okay. Yeah. You can schedule online 2 hours in advance. So if you want something like at 5 o'clock today, you have to get in there before 3 o'clock to schedule it.
Okay. Okay, no problem.
Now, I don't think I'm playing golf today, but it's not impossible I'd get a call from my buddy. So later probably works better than earlier for me.
Okay, no problem.
Although early would work. If early, if you want to do it at 2 or 3 o'clock in the afternoon and that's the only time you can do it, go ahead and schedule it. And if I decide I'm going to play golf, I'll block out up until 5 o'clock. So then you'll notice that you can't do it.
Okay, no problem.
Okay? All right, Joel.
Cool.
You want to head out now and pick it up later today, or you want to do one more problem? Okay. Let's go ahead and call this a session, and then we'll pick up from where we left off.
All right, cool.
Okay?
All right, thank you very much.
And this recording will be up there in a couple hours.
All right, cool. Thank you.